What is starch and how do you convert it? And what's up with this long sugar molecules? Let's go find out. Hey everyone, Distiller Greyling here, one of your favorite home and hobby distillers. This is part of my Back to Basics series, and today we are handling starch conversion. Now, to give yourself a representation of starch is when you have a potato and you cut it up and you see that on the knife there's like a bit of white residue or a sap. That is actually the starch of that specific potato. So today we're going to talk about starch in grain specifically. So starch inside the grains are tiny structures that the plant itself makes as a product of photosynthesis. Essentially, a starch grain is a well-packed storehouse of glucose sugar units. The problem is that these sugar units are in a form of compound sugar molecules or long sugar molecule structures like this one, and it's hard to ferment. To get these sugar molecules easier fermentable, we need to convert them and then break them up. Now that's where enzymes come in. Enzymes, they would attack the sugar molecule and these long structures, and they will break it up into smaller and simpler sugar units that we can easily ferment. Before we use these enzymes to break down and convert the starch, we need to prepare the starch or the grain itself. Now the grain molecule itself is a well organized and structured, and it restricts the enzymes from breaking it down. But this rigid structure of the sugar granule itself can be easily disrupted by gelatinization. If you've ever made porridge, that watery, grainy flour mixture that you have, and you cook it and you cook it and it starts to come like a thick paste, that's gelatinization. So first, let's take normal grain or unmalted grain. What I like to do is I use a ratio of 1 kilogram of grain. Now whether it is just grain on itself or a combination of different grains, but I take 1 kilogram of grain to 2.5 to 3 liters of water. I get my water onto strike temperature. Now strike temperature is the temperature just slightly higher than what you want your grain to cook at initially. So for this normal unmalted grain, I want to cook it at 90 degrees Celsius. So I would make sure that my strike temperature is slightly higher. Depending on the amount of grain you're going to cook, your strike temperature can be from 10 to 15 degrees Celsius higher than your initial cook is going to be. So use strike temperature calculators. They come in handy. I'll leave some of them down below in the comments and make it easier for you guys. So when you get your water onto strike temperature, you add all your grain gradually into your pot. Stir it as you add it to make sure there's no clumps and lumps. You get it to your 90-degree temperature, and now you will cook it. I will then cook it for 1 hour and 30 minutes to make sure that gelatinization works optimum and to the best. You will see as you stir this and it's cooking, it will get thick, and the thicker it gets and it gets that nice pasty feeling, and then you know, yes, gelatinization is taking place. What actually happens is that this rigid starch granule structure is getting disrupted and it's starting to swell out, and as it swells, it's becoming that pasty mixture of porridge that you can see as you are cooking your grain. Okay, now we have prepared our grain, but where do we get the enzymes? Unfortunately, for normal unmalted grain, you will have to add enzymes. So first up is Alpha Amylase enzymes. These are the big guns. You can buy them from your favorite distilling or brewing shop. I buy mine from Distilling. Look out for Dextrolique Plus in the Distilling shop. Make sure you read the instructions on the bottle to say exactly what your dosage is per kilogram grain you have, also at what temperature you need to add them. So as soon as you add the enzymes to your cooking pot where the grain is now gelatinized and nice and thick, and you start to turn it, liquefaction will start to happen. That's the part where these thick pastes now start to get to a fluidized liquid again. So what basically happens is you got these long compound sugar molecules, and then the alpha amylases come and they start to break it down and convert into a more smaller sugar that will be easy fermentable. But the problem is these sugar units are still not small enough to easily ferment. They are smaller but not simpler yet. That's why we need a secondary enzyme. In comes the smaller brother, glucose-amylase enzyme. Also a distilling, check for sugar leak. What happens now is the glucose-amylase enzymes take these smaller sugars that's already been converted, and they go and they divide it even more into simpler sugars. Now these sugars are the ones that we want that will be easy fermentable. Just like that. Now you have all these nice small easy fermentable sugars. Once you're done with both enzymes and you left it to give it enough time to work and get all those strains converted into smaller sugar units, you can then cool down and ferment it. At the end of the gelatinization phase, just before you start to add the enzymes, and after you've added the enzymes just before you cool down, you can do a starch test. What I basically use is normal iodine to do my starch test. So what you do, you scoop out just a small bit, say a tablespoonful of that paste you've made now before you add the enzymes, put it on a separate plate, take your iodine and you drip it on there, and you check for starch color. Dark purple to dark blue to almost black is a very good indication that you've cooked your grain very good and there's a lot of disrupted starch inside that pot. If it does come out a bit dark pinkish, you might just want to cook it a bit longer, or maybe at a higher temperature, and just give it some more time to let all those starches get disrupted and be ready for your enzyme adding. Just before you cool down, you've added your enzymes now, and before you cool down, you scoop out again a bit, put it on the plate, take your iodine, drip a few drops, and you look at it again. Now here we are looking for lighter colors. We're looking for an amber to almost yellow color. That will show us that all those disrupted starches that we had there in the beginning that was so dark has now been converted and changed by all the enzymes, and it's not all these simple sugars, and that's why it's so light yellow and amber color. Then we know it is good and ready to ferment. You can cool it down and go on with your fermentation. If it is still darkish, maybe dark purple or just starting to look dark blue, what you can do is repeat everything again, or just go to your enzyme steps and just give your enzymes more time to work, or maybe add a bit more enzymes just to see that you can get that last bit of conversion more to a point where it gets to that yellow color. Now let's talk about malted grain and how is it different from normal grain. This is my very basic and simple explanation, but malted means is that the grain they took and they soak it or steep it into warm water, take it out and dry it again, and then back into the water up until the time when it starts to germinate. As it germinates and it starts to sprout and it starts to grow that initial root, they then stop the germination process by killing it, and then they are ready for action. Now this is a lot of information, but what does it mean for us? At that stage when it starts to germinate, it releases natural enzymes. These enzymes help to assist with the growth process of the grain itself. Now after they have killed it and it's now dried again, that enzyme stays there until it is basically soaked and heat up again, and then that enzymes will start to release. And that's why we can use malted grain as the only source of enzymes in our mash or our pot that we are busy cooking. You can use a combination of normal grain and malted grain to let the malted grain act as the enzyme source to help with the starch conversion and get your simpler sugars that you need for fermentation. Now the process of cooking and gelatinization of a malted grain is slightly different from the normal grain. I've got two ways that I'm familiar with using malted grain. I use the same water grain ratio as I did for a normal grain, but I use 1 kilogram of malted grain for every 2.5 to 3 liters of water. Now my initial cook temperature for my malted grain is lower. I want to get it at 65 degrees. So my strike temperature will be slightly higher. As soon as my strike temperature is fine, I will start to add my malted grain Whether it's malted on its own or a combination, I add everything into the pot and I start to stir, make sure it's at 65 degrees. Now here's where my two malted methods split. The first method, I will then at 65 degrees Celsius cook for 1 hour and 30 minutes. In that time, because the enzymes is already inside the grain, your gelatinization will start to happen and that structure will start to get disrupted, and as it gets disrupted, the enzymes will attack them and start to break them down, and you will get liquefaction immediately. So you will have that gelatinization getting thick and then liquefying immediately, and that will happen in that whole time that you're cooking. So it will not become as thick of a paste, but don't worry, it's still doing its job and it's happening. After that hour and 30 minutes, you can then cool down and ferment. So the second method for the malted grain, I call my 3-step temperature range. What I do there is I also start at the 65 degrees. So I keep it at 65 to 70 degrees Celsius for 30 minutes. After 30 minutes, I will then increase the temperature to above 70 degrees Celsius. Once it has reached 70 degrees Celsius, I will then keep it between 70 and 75 degrees Celsius for another half an hour. When that half an hour has elapsed, I will heat it up again and take it to above 75 degrees Celsius. Then I would keep it at 75 to 80 degrees Celsius for another 30 minutes. After that last 30 minutes step temperature range, I will then cool down everything and ferment it. The reason that I use the method 2's 3-step temperature range is that I ensure that I have a very good and sufficient structure disruption, and also that the enzymes can do their job on all the temperature ranges. The higher your temperature is, the more disrupted that structure will become, and that's why it's easier for the enzymes then to start to convert and break down those long sugar molecules. But be careful not to take your temperature up too high. Anything above 85 to 90 degrees Celsius will kill that enzymes totally. So don't take up the temperature too high if you're using malted grain and you're not adding any enzymes at all. For both methods of the malted grain, you can do a starch test before you cool it down. If it is still a bit dark, purple or bluish, it just means that you need to cook it a bit longer, or maybe at the different temperature ranges. But normally I find that hour and a half cooking time, or the 3-step temperature ranges from 30 minutes to 45 minutes perhaps, is definitely sufficient. I hope you guys understand a bit more about the process of starch conversion. I will leave the steps of all the methods that I talked about today in the video descriptions. You guys can have a look at it there. If you like this video, please give it a thumbs up. It helps me out a lot. If you got any more questions, leave a comment down below. I will definitely answer your questions to the best of my knowledge. And if you like the content you are seeing, please subscribe and hit the bell icon so you do not miss anything. This for me is it today. As always guys, remember to be awesome, to be kind, and be yourself. Cheers.